Okay, let's talk about one another important concept for the second order linear differential equation, okay? It is Wronskian, okay? So basically, like as I told you, it is second order linear differential equation, which means you need two different particular solutions, okay? But like think about it. The first one is x and the other one is 2x, and they are actually same. Does it make sense? So we have to check the Wronskian before decide like if they are two different particular solution or not, okay? So like Wronskian is defined like this way. Look at that. Like, let's say y1 and y2s are two solutions of differential equation, second order linear differential equation, okay? Then the Wronskian will be calculated like this way. Wronskian is the determinant of y1, y2, and y1 prime and y2 prime, okay? So like this is the Wronskian. And let me give you like one example how we can calculate the Wronskian, okay? It's just practice, okay? Here we go. So if I say y1 is cosine t and y2 is sine t, then the Wronskian of y1, y2 is equal to determinant of y1 and y1 prime and y2 and y2 prime. And determinant can be calculated by how? AD minus BC. Do you remember? Okay. I say A, B, C, D. Okay. And then AD is cosine T times cosine T minus BC sine T times minus sine T. So which is equal to cosine squared T plus sine squared T. Wait a minute. We know about this, right? It is the trigonometric identity, right? Which is equal to 1. Is that okay? And let me give another, okay? Look at B. Y1 is T and Y2 is T times it's a T, right? So the Wronskian of this one is equal to the determinant of Y1 and Y1 prime and Y2 and Y2 prime. Definitely is product, right? And T prime is 1. So it's the T plus T times it's a T. So do it again, AD minus B, right? And A times D minus B times C, which is equal to T e to T plus T squared e to T minus T e to T, which is equal to T squared times e to T, okay? And well, at this point, we have to know why we have to check the Wronskian, okay? But again, as I told you, we are talking about second order linear differential equation, okay? Which means you need two different particular solutions, right? But for this previous two problem, they are exactly two different particular solutions, okay? But just in case, like if they are, like one of them is belong to the other one, which means, for example, like T and 3T, T and 3T. Actually, they are same thing because we just multiply constant, right? Which means it is belong to the other one, which means they are dependent, right? So the meaning of Wronskian is this, okay? If the Wronskian is equal to 0 and they are dependent to each other, which means we do not have like two different solutions, okay? But we have only one. Does it make sense? But if your Wronskian is not equal to 0, then we guarantee those two given solutions are independent, which means we can say those are the like two different particular solution of your linear second order linear differential equation. Okay, I stated that idea in theorem number 6. Look at that. Okay, it is the given second order linear differential equation. We assume y1 and y2s are two solutions. Okay, then if the Wronskian of like these two solutions are not equal to 0, then we can say the linear combination of y1 and y2 is the general solution of your second order linear differential equation, okay? So let's talk one more, okay? Here we go. So we say, like, if the Wronskian is not equal to 0, then y1 and y2 form a fundamental set of solution. Is it okay? That is the like meaning of theorem number 7. Is that clear?